over it. So translation. We did transcription. We did translation, but I want to go over it again and record the video for you. So my code is interpreted, okay? You have a code that comes from where? Who creates this code? DNA by making what? DNA houses the instructions. Before protein, DNA makes RNA, okay? RNA holds a message to make protein that DNA provided. So mRNA leaves the nucleus, and where's it going to move to help make protein? Cytoplasm to find the ribosome. Good. So, yes, this is going to be good. So it's going to look for a ribosome to help make protein. And then every, 3 letters is read as a code, and that's called a what? Codon, okay? Codons are found on what? What type of RNA? Codons are found, and I had you type that on the bottom of your notes. Codons are found, and if you didn't, no, not tRNA, mRNA. Codons, so if you don't have that, add it right now, are found on mRNA, okay? So you don't confuse them. Then, anticodons come on who? tRNA. And tRNA, by definition, does what? Transfers. T for transfers. What are they transferring in? Amino acids. What amino acids do? They form protein. They are the building blocks of protein. If you forgot that, write in your notes, amino acids are the building blocks of proteins, okay? So anticodons are always going to be the corresponding end bases of the codons. So if a codon, and again, we scratch this off, now I'm going to do this, so it's different. Let's say, because a codon should be 3 letters, if my codon is GGC, and this is uncovered, the anticodon is CCG. I'm going to give you another one. If my codon is AUT, I'm sorry, AUC, what's my anticodon? No. UAG. Because anticodons are, so put it over here, this is my codon, this is my anticodon. So the first mistake was saying the same letters. The second mistake was saying a T. RNA never has T. Instead of T's, they're U's, okay? All right, so we're going to pretend we're doing protein synthesis. We're going to imagine DNA unzipped, and this is one side of the DNA strand, which is going to be used as a template to make RNA, okay? Tell me what the RNA is going to look like. Good. If you're struggling with the U's and the T's and the A's, make a DNA, okay, and erase the T's and replace them with U's. It's that easy. Because if you're not sure if you should put a U with the A or a T with the A or whatever, do the corresponding DNA strand and then erase all the T's and make the U's. Now, who could tell me how many codons are in this mRNA? Raise your hand. And I better have somebody else besides Gabriel. Who could tell me how many codons, or I'll ask another question. Who could tell me how many letters makes up a codon? 3. Where are codons found? mRNA. Who could tell me how many codons are on the strand? Nope. 3. Let's underline them. 1 codon, 2 codon, 3 codon. I'll make this darker. 1 codon, 2 codon, 3 codon, okay? Who could tell me what tRNA is going to look like? Raise your hand if you could tell me that. Who's going to go for it? tRNA has the corresponding bases to mRNA. Who could tell me what tRNA will have? Go for it, Nick. Nope, corresponding. So what corresponds with A? Sabrina. U. I need a darker letter? U. What's next, Sabrina? U. What's next? A. What's next? Perfect. Corresponding bases to mRNA. So just like in your animations where you had one side and another side, the other side is corresponding. The difference here, these don't connect. They connect for only a second. What is tRNA going to have on it? Anticodons, every 3 letters. So these are my 3 anticodons. What else is tRNA going to have on it?
A message?
No, the message is in mRNA. tRNA brings in what's going to build a protein?
Amino acids.
Amino acids. tRNA carries, and look at this picture. I'm going to go back here for a minute. Here's my tRNA, right here, this blue thing. It carries my anticodons, and this little dot here is my amino acid. I'm going to show you now an animation that shows this process happening, okay? All right, so you're doing great. You answered that this is the codon UUU, which is on mRNA. tRNA is going to bring the anticodon, which is AAA, attached to a specific amino acid. I want to show you those codes. So remember, this is AUG, and it had the amino acid MET, right? So go to the next page in your notes, and you're going to see there's a code of amino acids. So if I look, I already forgot the code. What was it? AUG. If I look for AUG, look at the amino acid right here, MET. You see that? mRNA holds the information of what amino acid to bring. Let's look at the next one. The next one was AAG. Who could tell me what amino acid comes with AAG? Look at the chart.
I can't see the chart.
It's right here. You don't have it in your notes? LYS. Where are you? AAG, LYS. Look at the animation. AAG, LYS. Now, UUU. Who could tell me what that brings? UUU brings what amino acid? PHE. Where is it?
Up on top.
Up on top. Here we go. Let's watch the animation and see if that's right. UUU is my codon. tRNA is going to bring AAA, and look at the PHE. Okay? What's my next codon? Say it out loud. GGC. What's my anticodon? CCG. Who's bringing it?
Transporting, tRNA.
tRNA. What amino acid is coming?
We're not supposed to know that though, right?
You're going to get this chart.
Oh, okay.
GGC, right here, don't get confused. The mRNA holds the message. The message says, GGC says, bring me this amino acid, okay? tRNA just brings it. It doesn't decide who's coming. All right, so let's watch. And you're going to see the end is going to happen. I'm not going to keep playing. There we go. We got our glycine. Now what's my codon?
What is, I can't see it. C, is that a U?
U.
AA.
AA. What's my anticodon?
What
A-U-U. Good. What amino acid is called? UAA. Right here. Look what it says.
A stop.
Stop. No more protein. Watch. So we go here. UAA. Don't do anything. That's RF means release factor. Release the protein so that your body can use it. There's protein synthesis. I'm glad you're wowed. All right, so here's what I want to tell you on the test. On the test, I give you this chart. Who holds the codes of the chart? mRNA. Write that in your notes right now. Don't forget. mRNA holds the codes that say, bring me an amino acid.